Electric cars, also known as electric vehicles, EVs, are gaining popularity as a cleaner and more sustainable alternative to traditional gasoline-powered vehicles. These vehicles rely on electricity stored in batteries to power their motors, eliminating the need for fossil fuels and reducing harmful emissions. Understanding how electric cars work involves delving into the key components and processes that make them an efficient and eco-friendly mode of transportation. At the heart of an electric car is its battery pack. This pack consists of numerous individual cells that store electrical energy. These cells, typically lithium-ion batteries, are similar to those used in laptops and smartphones, but on a larger scale. The battery pack is rechargeable and provides the energy required to drive the electric motor. When an electric car is plugged into a power source, such as a charging station or a home outlet, the battery pack begins to recharge. This process involves converting electrical energy from the power source into chemical energy stored in the battery cells. The charging time varies depending on the battery capacity and the charging infrastructure used. Once the battery is charged, the electric car is ready to go. When the driver activates the accelerator pedal, the electric motor receives an electrical signal from the car's control system. This signal instructs the motor to convert electrical energy from the battery into mechanical energy, which propels the vehicle forward. Unlike internal combustion engines found in traditional cars, electric motors have fewer moving parts and operate more efficiently. This efficiency results in a smoother and quieter driving experience. Additionally, electric motors provide instant torque, allowing electric cars to accelerate quickly and effortlessly. To control the speed and direction of the vehicle, electric cars utilize a power electronics system. This system manages the flow of electrical energy between the battery, motor, and other components. It ensures that the motor receives the appropriate amount of power based on the driver's input to maintain the desired speed. Electric cars also employ regenerative braking, a feature that enhances their energy efficiency. When the driver applies the brakes, the electric motor switches into reverse mode, acting as a generator. This process converts the kinetic energy of the moving car into electrical energy, which is then sent back to the battery for storage. By capturing and reusing this energy, regenerative braking helps to extend the vehicle's range and reduce energy consumption. The range of an electric car refers to the distance it can travel on a single charge. Factors that influence the range include the battery capacity, driving conditions, speed, and the use of auxiliary systems like air conditioning. As battery technology advances, manufacturers are continually improving the range of electric cars, making them more comparable to traditional gasoline-powered vehicles. To make electric cars more practical for everyday use, charging infrastructure is essential. Charging stations are becoming increasingly prevalent, allowing electric vehicle owners to recharge their cars while on the go. There are different types of charging options, including slow charging at home, fast charging at public stations, and rapid charging at dedicated stations. The charging time varies depending on the charging method used, with rapid charging offering the quickest recharge times. In conclusion, electric cars operate by using electricity stored in batteries to power their motors. The battery pack provides the energy needed to drive the electric motor, which converts electrical energy into mechanical energy. Electric cars offer numerous benefits, including reduced emissions, improved efficiency, and a quieter driving experience. As technology continues to advance and charging infrastructure expands, electric cars are poised to play a significant role in shaping the future of transportation.